Okay, so let's start. So this is our uh device for this project, which is forearm implant. Our our member is Q Waiting, Yap Chi Hong, Nurul Fatihah, and me, Amirul Fahmi. So next. Okay. So for the production, we are going to design an internal fixator which can be used by the people who need to recover their bones, especially at the radius part, the radius bone. The main purpose of the design is that people who have oblique fracture at the forearm bone radius can be healed as soon as possible and buy the internal fixator at a lower price. So a broken bone must be carefully stabilized and support until it is strong enough to handle the body's weight and movement. Until the last century, physicians relied on casts and splints to support and stabilize the bone from outside the body. The advent of sterile surgical procedure reduced the risk of infection, allowing the doctors to internally set and stabilize fractured bones. Our objective is to conduct a design research on an internal fixator for oblique fracture at forearm, to understand the benefit of internal fixator for humanity, to learn the design of the internal fixator and its function, and to design a forearm implant with simple structure.
Fahmi, my turn,
Oh, okay.
Problem definition is
Okay, can you turn on your camera to the presenter group?
Okay.
Sir, my line is bad.
It's okay. It's okay. I hope others you can share your. Yeah.
Okay. Our problem definition statement is to design an internal fixator for fracture at the forearm of the patient in order to keep fractured bones stabilized and in alignment. The design named twin cylinder internal fixator is an implant used to connect both fractured bones with adjustable string. The product consists of two plates, one set of strap and screw. The plates are inserted on bone and connected by straps where its function is to adjust the pressure of plates. So the design is suitable for every age groups of patients, although the size of bone are different from each other. We are going to do research on a similar design, come up with the idea and sketch it. Then we have to choose the most suitable and logical design from these sketches. After that, developing and making improvement on the design and product are need to satisfy patient needs. Fatihah.
Okay, next for product design specification. In the performance, the device was designed as double cylinder and a strap. It can be adjust the tension of the strap by using internal screws, and it's easy to plug on the patient by using clip as handcuff mechanical setup. The device should be fit by custom design. Once the clipping is done, the doctor only needs to find the suitable pressure for the bone. And once the healing process is done, is it easy to remove? Next. Okay, for product lifespan, we target that this product will be last for about 3 years to stay on the market. And size for this product is 18 millimeter until 21 millimeter for diameter of normal adult bone, radius using magnetic resonance imaging MRI method, and 60 millimeter until 100 millimeter for each ring plate length. And the estimate weight is 50 until 68 gram for a piece of ring plates, or 100 until 130 gram for the set of ring plate. Next. So the materials that we use is stainless steel for screw and strap, and titanium for strap because it's lighter. For standard and pattern, this product complies with standard ISO 13485 2016 Medical Device Quality Management System, and then ISO 19227 2018 Cleanliness of Orthopedic Implants. Third, ISO 14971 2019 Medical Device Application of Risk Management to Medical Device. And last, ISO 9268 1988 Implants for Surgery Metal Bond Screws with Conical Under Surface of Head. Okay, next. We assume for the cost is about 500 until 700 ringgit Malaysia, and our target customers is from a hospital, clinic, private medical doctor, patient with forearm bone fracture, and the quantity of this product consists of 4 plates of strips and also screws. Next. Competition locking plate system available in Malaysia is manufactured by GPC Medical and Siora Surgical. And service life, this product can last for 10 years and above. For the ergonomic, the design is made safe and suitable for human bones so that it's easy to handle, operate, set up, and store. Next. For the safety, first, it will not harm the patient. Second, the material that we use is non-toxic to human tissues or fluid, and there is no sharp corners that will hurt the human body on the design. For the process, doctor will adjust the strap to determine the right pressure on the patient's bone, and shelf life storage time without degradation. Okay, next. For the morphology chart, we have 4 morphology chart, and for the first morphology chart idea is from Fahmi, and that consists of plate, connector, hinge, screw, and gear. And then he produced 3 concept designs, which is design A, design B, and design C. Next, morphology chart 2. Okay, the idea is from me, which is consists of 2 components, which is plate and screw. And I have 3 also concept design, which is design D, design E, and also design F. Next, for morphology chart 3, the idea is from curating that consists of 4 components, plate, hinge, screw, and bolts. And they have 3 concept design, which is design G, design H, and design I. Next, for last morphology chart 4 from Yap Chi Hong, they have 3 components, which is plate, screw, and connector. He produced 2 concept design, which is design J and design K. Okay, next, I will pass to the next presenter.
Okay, for the evaluation metrics part, we have developed screening metrics and scoring metrics. For screening metrics, we have 12 design concepts in our group that need to be read in these screening metrics, and the criteria used to determine their ranking, determine our design ranking, including lightweight, easy to operate, adjustable size, low production cost, ergonomic, and resources required. So finally, there are 4 design concept are selected to proceed to scoring metrics based on their net score. Okay, for scoring metrics, we give a higher percentage to the criteria adjustable size, because this adjustable size is our design highlight. So we give 25% in rating the design. So the design A, we are going to develop design A from these scoring metrics based on their total mark. Okay, next. Then the reason why we choose design A are the product is easy to operate and it has strap that can be adjusted based on bone size. And this design looks stable when holding the bone until the healing process is done. And this product is made of the material that easy to find on the market, and it is high durability and safe to apply in human body. This is the exploded view of our product the before improvement made consists of hinge, plate, screw, and strap. Next. Our design got a new improvement after we realized our design is too complicated. First, we were using gear in our previous design, but we removed it, and because we were unable to research the gear, and we have changed it to simpler design, but remain our working concept, which is adjustable stress. The second change is the hinge shape became curved, so the hinge will be more stable. They will fit the plate shape, and also it is easy to install, and the customer will have no foreign body sensation. This is a exploded view sketch after the improvement made. The hinge become a curved shape, and also we replace the gear with just a simple screw used to fix it, fix the strap and the plate together. Okay, next. The strap are inserted into the plate and fixed by the screw. Then the quantity of the screw that used to fix the strap and plate is not fixed. You can add the quantity of the screw that you want to use, depend on the patient situation. If you want to increase the stress, then use more screw to fix it. Then it will become more stress on that strap. Okay, next. I will pass to Fahmi for 3D modeling part.
So this is how our device work. So first, before beginning the surgery, two straps are inserted into two plates and fixed by two screws. And then during the surgery, two sets of plates are used to hold the fractured bone. The size of plate has been collected for custom fit, so it should fit the right size of user's bone. And then when the installation is done, doctor will check the length of the strap and they insert into the plate until they achieve the right measurement for the pressure. If the straps are too tight or loose, they need to unscrew straps and adjust the length with the right tools. I'm suggesting forceps and screw back the straps. So for reduce the stress of the bone, doctor should decrease the length of the strap insert into plates, and to increase the stress of the bone, doctor should increase the length of the straps insert into plates. Then strap will be tighter and create a stronger force to pull both sides plates. Increase the quantity of screws that used to fix plates and straps, and hence straps will be tighter. Next. So this is the SolidWorks. Um, so as you can see, there is two plates, cylinder plates, and there's hinge, and you can see there is a screw. So that's the screw that hold the straps. So next, the isometric plan. So here, next. So this is exploded 3D modeling. As you can see, we insert the strap into the plate. Yes, and then there is screw. So next, to remind you, the strap is made like a chain, watch chain strap. Our watch chain strap. So for SolidWorks, it is a bit difficult to make, but you can refer strap watch chain strap at Google. So next. So this is our final render for the 3D modeling. So our suggestion is, since the straps are inserted manually into the plates and the stress of plates is also adjusted manually, magnet can be used to replace strap in order to simplify the installation process. It is because magnets are able to attract each other if they are inserted into plates. As a result, the plates can be connected to each other automatically because the magnetic force. However, this technique still needs more research by scientists. So this is our reference for this whole project. Then, thank you. That's it. That's all from us.
Thank you to group 3. Yeah. I think I just is it internal fixator or external fixator?
Internal fixator.
Internal fixator. So everything will put in the body. Yeah. Okay. Any question for others? Yeah. Others group or the attendance, yeah, from the attendance, you can ask any question. If you have any question regarding about the concept or what, you can give detailed discussion today if you have any question. Okay, I think everybody is didn't give any question. Yeah, we go to another groups. Group number 2. Group number 2.
Yes.
Okay, you can turn on all the camera. Okay, what's another one? Then you can start your presentation.
Hi, hello. Can you hear me?
Yes, we can hear you.
Okay, thank you. Hi, good afternoon to everyone. We are from Group 2, and we are now presenting our major project for Intro to Design this class, where our design will be doing total hip replacements, where we always showing love to your hips. Our group member will consist me, Ong Ling Chuan, my fellow friends, Hang Jing Tian, and also Hu Hui Wen, and lastly, our beloved Muhammad Suaid bin Razali. Okay, next in our group, our group member will explain what we have done in the projects. So I will take over by Hui Wen. Thanks.
Next slide. Okay, so this is some introduction about our project, which is total hip replacement. So it's an internal fixation device may be used to keep fracture bones stabilized and in alignment. The device is inserted surgically to ensure the bones remain in a optimal position during and after the healing process. They are healed together with a special implants such as plates, screws, nails, and wires. So this internal fixation allows shorter hospital stay, so the patient can discharge earlier, and patient return also reduce the incidence of improper healing and this which is meaning healing in an improper position of a broken bones. So next slide. So this is how it works. And the left-hand side is how surgeon insert the implant into our pelvis. And the right-hand side one is the how the implants function in our body, how the implants works on our body lah. Next. So the problem to be solved is provide structural supports and replace for remove hip joint and sustain the body weight after removal of hip joint due to osteoarthritic or mechanical damage. Next. And these hip implants give a lot of importance to us. So the first one is it can relieve your pains because some of the patients that have tumors over their pelvis or they have an old cartilage. So this will make the like a quite big friction to their bones, so they feel pains. But with this hip implants, they can relieve the pains. The hip replacement can provide a dramatic reduction in pains. So, and the second one is improve mobility and hip function. So this with this implant can so allows you to get back to working without a restraint, okay, and long-lasting effect also. So the carbon evidence shows that 80 or to 85% of hip replacement are still working for 20 years after they were inserted. So this is very long-lasting product. Next. Because these hip implants already invent many years already, so there's a lot of related work have been done. The first one is the complex pelvis reconstruction using patient-specific instrument segmentation, and a 3D printed custom implant following tumor resection. So these things is done by a group of a doctor from a department of orthopedic surgery of Hospital Boston, Massachusetts. So they set about a limb sparing extra articular resection of the sarcoma, which is a type of a cancer that begins in bones or in the soft tissue of our bodies. So with this, consisting of a 3D custom printed pelvis implant and a proximal femur extendable prosthesis. And the second one is the total hip replacement, which is called a direct anterior approach. So as you can see the photos at the right hand side here, there's two ways to like insert the implants. One is anterior and one is posterior. So what's the difference is the direct anterior approach that can let the surgeon cut a smaller incision near the front of the hip. So this allows for a remove of damaged bone or cartilage and without damaging surrounding muscles and tendons. So the surgeon gently push the groups of muscle and ligament aside and insert the implants and then remove them back to their proper position. So compared to the posterior approach, the surgeon has to cut a very big incision, about like 12 inches. So the patient will have take a long time to recover. Next.
Okay, next we will talk about our briefly design, where our hip implant consists of about four components, which is the acetabular components, the plastic liner, the femoral heads, and the femoral stem. So what does each part has and what does it do? So the first thing is the acetabular cup. It has a porous coating that bones can grow into weights, and which also have a locking mechanism to hold the liner. And it also has on the surface are used to be filled with screw to fix the cup to pelvis. Next is the plastic liner. The plastic liner actually act as a new cartilage for in our body. Then the most common material is made by polyethylene, which is plastic, and some are made by metal or ceramic, but we choose for plastic because it's more commercial and it's better and lasts longer. Next is the femoral heads. It is the ball of the hip joint and the second portion of the femoral side of the implants. It is made of a couple of different materials such as metal, they're made out of cobalt chromes or like maybe ceramics, but depends on different situations. And next is the femoral stem. Most commonly made out of titanium because titanium is the most suitable and the most commercially used in biomedical areas for the biomaterials. And next, for the stem, it can be implanted in a cemented manners in which acrylic bone cement is used to fix the implants with bone. Next, we use a titanium screw to fix the acetabular shells or the acetabular cup just now in the acetabulum. But it's not easy to corrode, so high tensile strength and corrosion resistant. Based on these characteristics, so we use titaniums. Next. So this is like how we actually, not us lah, but the surgeons, the doctor, how to implant their hips implants into the pelvis sites. So first of all, we have to cut out the bones, okay? Then the hip is dislocated and the femoral head is removable. Then with the acetabulum and the femoral shaft rim, as we want to create the hole for our implants. So in the third picture condition with the acrylic change, you can see there. So then the C part is the acetabular and the femoral components are placed into the bones. Okay. Then the post-operative condition is like the acceptable component is on the pelvis there, and the stem is on to the bone, femoral bones there. Next. In our design, we have some product design specifications where we want a performance that can support a wave, at least for an adult, and that can last for a long time. That actually also can help with a bone regrowth, because we actually want to help recover some of the bone that are loose during the surgery or the incident that he does, and can withstand high forces, as we have just said. Not only with the weight of an adult, maybe some what is that called? Frictions forces when you are walking. Yeah, that's the force lah. For safety, we do not pose a high risk of conflict infection, so we are using like material that is not like easy to corrode. So we must be resistant to corrosions lah. Next is our product must be stable, not loose, or else our bone will be go away. Our leg will be in a weird positions that is inhuman. So we also use material that is high durables, biomaterials like weighted, to ensure that bone is stable. Yeah, at the same time. Next, for ergonomics, we want to because hip implant must be on because hip implant is an internal fixature, so we want the doctor to be comfort using our products and easy to be used lah. As for the patient, it will be comfortable. It's like just like all your old bones, just replace with a new one, and we doesn't have like a weird feeling that is a machine, it's a replacement in our body. So we want to aim for a smooth movement that will be like not machiney mechanics, like that. Then for marketing, we aim for like the affordable prices for like the average people's families, kind of that. So we are aiming for lower prices, not too high. So we also have to, of course, minimum maintenance lah, because our hip implant just said it will be a last longing time effect. So we don't want every time, like every 2 weeks or 3 weeks, 3 months or something, have to go maintenance. So we make sure our product is safe, nothing have to maintain every single like months or like years or something. So it will also lower the cost for the maintenance fee lah. Okay, next. Then is our quality function deployment lah. So we have some design characteristics where we match our custom designs, like when like the safety and the comfort is very high, the reliables and the safe performance for the biomaterial is very high also. And this is the table that we have come up with lah. Okay, next.
Hi, so I'll continue with the morphology chart. So as you can see here, we have included 11 designs, a combination in our morphology chart. So we will have different, so we have a total of 4 parts, and we will, for each part, we'll have different design, diameter, and materials. So yeah, as you can see here, we have design 1, 2, 3, 4, and 5, and 6. Yeah, so this is for femoral head and stem. And this is for design 7 to 11. And this is a Stablin cup and the liner. And for this is the femoral head and stem. So how do we pick our design for our final design? So we are using this concept screening matrix to finalize our design. So first we need to shortlist the design into 4 designs, so that we can focus more on like those 4 better designs. So first, this is like more general, and we don't have like scoring, and we just like do simple advantage and disadvantages, and yeah, and we finalize, and we just proceed for 4 designs, which is design 2, 4, 7, and 8, and 10. So next, yeah, so this is our finale, yeah. And we will have these 4 designs, and we just rate each design with our criteria, which is lightweight, easy to operate, adjustable size, low production cost, ergonomic, and resource required. So we rate each designs according to different weightage for these criteria. And after that, our final design, which prominence from all the design is design 2, concept 2. And next, I'll pass to Shai.
So you are in the design concept. Next. So this is a vestibular measurement. Next. So these are the liner. This is the head, and this is the femoral stem. So this is the last one, the screw. So we use 5 components in our hip implant. This measurement that we already decide of this measurement, we already fit with the real bone, and it is suitable to be used. Next. So this is our exploded view. This is the way how we gonna connect all the components. Next. This is the table cost. So the first item is Estabilium cup. Specification made by titanium. We use quantity is 1. Weight of Estabilium cup is 200 grams, and estimated cost is in about 20 ringgit. So the second item is the liner made by polyethylene. So we use 1. So we as a expected weight is 50 grams, and it's very cheap. So the third item is head made by titanium. So we use only 1. So the weight of the head is 275, and the cost is 26.90 Malaysia ringgit. So the fourth item is stem made by titanium. So we use only 1. Weight per weight per stem is 500 grams. The estimated cost is 48 ringgit to 50 ringgit. And the last part is screw. Quantity is based on the how many we want to use to make it stable. So weight per pieces is 60 grams, and the cost is 5 ringgit to 6 ringgit lah. Next. So as the conclusion, advantage of hip implant, exposed to the biomedical and the market of biomaterials such as TI6AL4V, ultra high molecular weight polyethylene, fiber reinforced polymer, HDPE, and so on. So appendix. This is our discussion based on our project. So we take a picture. So this is our group discussion on WhatsApp. And then next. That's all from us. Thank you. See you next
Okay,
time.
thank you very much from group 2. I think all the presentation is good, but I didn't see yet your rendering of the model. You have?
Yes, sir.
You have which one?
Uh,
Look, it's not rendering.
PGT, do you have the picture that I sent in the group?
It's okay if you have the rendering models. Yeah, you
Wait,
can
sir.
add in the slide presentation. After that, you can send to me in the e-learnings. After that, I will see.
Wait, sir. I have.
Okay.
So this is the so this is the picture that we already used to fit with the bone.
Okay, I think you can add that one. The rendering model you have that you render the models. You use rendering, use SolidWorks or another software.
SolidWorks.
SolidWorks.
Yeah. So this is the final look, and for the rendering, I think this is the last part. I think this is the last part.
Okay, then you can send to me later. Okay, Razali. Okay, to all, any questions? Yeah, any question to this group? Yeah, Ali Fatus Wahyu, you have any question or you have inquiry, some things we can discuss here. Erika, Medica, Catherine, Ronald, Yuri Tuna, you have any questions? Or you want to say something here? Okay, to all?
Any comments?
Any comments? That is good or not? Razali memang tak okay pun. Today you look more serious, Razali. It's not like previously. It's okay, no problem. It's good. Okay, if not, we continue with the group number 4.
Thank you, Doctor.
Yeah.
Thank you, Doctor.
Most welcome. Group number 4. Okay, Naim, Lim, another two. Zaidatul, okay. Another one. Moment.
Yeah.
Yeah, moment, yeah. Okay, you can start.
Going to present with one short video first, then we will begin our slide presentation.
Good.
So Zaidatul, can you share the video?
Yiteng, can you just share the video from your side?
Oh, okay, wait.
Okay.
Can you all hear the voice? Okay.
Introducing tibia chain fixator. This fixator fits to any types of tibia fracture. Most of the available products tackle only one type of tibia injury. They have limited length and parts are sold separately. They have limited shape and size and also limited range user. Tibia chain fixator are simple and safe. They are lightweight, can tackle all types of tibia fracture and have adjustable length. They can be shaped easily, can be installed to anyone, and can tackle all types of tibia fracture. It is also have safe material for human's body.
And so this is our video presentation, and now I will share our slide presentation. So good afternoon, everyone, and good afternoon to Sir and all of our fellow friends. And we are from Group 4. So allow us to present our design, which is chain fixator. It's for the choice. So I proceed our presentation to Daidato.
So as the introduction, this is the internal fixator. There are various type of tibia fracture. They are divided into 5 to 6 different parts. For tibia fracture, the most common classification is Schachter classification and Hall and Moore classification. Due to their different condition, the installation for the internal fixator for these fractures are different too. Most of the cases, a specific fixator is for a specific type of fracture. In addition, the existing fixators that are now available have specific sizes. Only certain sizes are suitable for the patient. If the patient is a kid, for example, it is a bit difficult to find the suitable size that might be suitable for them. The size may be too big for them. Furthermore, the existing internal fixators have many parts, and some of them are not in one set. Some parts are sold separately and increase more cost to the patient. Next. So for the project background, first is the problem statement. What we find from the problem is that the existing tibia internal fixator have limited size, which is not suitable for every patient. The existing tibia internal fixator have fixed shape, and most of the fixator have complex part, and they only available not in one size and not in one set, and have their parts sold separately. Next, for our objective, first, we aim to design and develop an internal fixator that can be adjustable to any size and the shape is suitable for any type of tibia fracture. Next, to develop an internal fixator that is simple and do not have complex procedure. Next, we aim to design an affordable and low-cost tibia internal fixator.
And we go to the concept development. At first, we have four important concepts. Firstly, of course, we need to have the affordable price. And then, of course, the material must be very durable. And then for our green, the plate must be thin and does not affect daily life. And it also have universal compatibility. And then this is a list of our market analysis. We have some market like AAP implant, Amplitude Surgical, Brown Holding, and some more. And then we go to our character feature design. Nice. Yeah, this is what we expect for our feature design. It's like the product is made by titanium steel and covered by a plate of gold, so there's less many moments and it can never be rusty. And then the product design must be very easy to produce and to put it together and to make any shape to hold more crack. And it also must be optimized support placement force. And then the product must be very cheap, as it the featherweight and eco-friendly. So the product could be soft in skin or taken out after the healing is done. And then finally, the product should be able to connect between plates because we're gonna need more plates to make our many shapes, and it should be able to hold between plates and should be able to disconnect.
Okay, so this is our product design specification. So the product will be used at the tibia fracture, and the product can be used by at least 2 plates to connect it longer and shapely. And the product can be used one-sided of bones or both sides. The strength of the product can like hold up at least 3,800 Newton if the medical plate collapse. So the size and the weight is the normal product. Length is about 3.2 centimeter, or recommend use with custom length according to the calculation for fracture by physician. And the size of the product could be getting smaller and as the product shapes changes, and there is no limitation of the length and of the combination of the products. The thickness of the product is about 1.5 millimeter, and the weight of each plate from the product is roughly 8.3 grams and different for custom review. So our main target customer is the people who have broken bones, which is under proximal tibia fracture type 4. And these below are the standard and the patterns we take for reference, which is we had presented at the previous class before. So I will not be detailed explained in this presentation. So the service life can last for about 10 to 15 years, and it is advisable to recheck and perform recheck once in a while, and all critical parts should be replaced and serviced as long as the product is being used. So as for the safety, this product is safe for human body,
and the product is designed to do not cause any inner damage to the user. And since it is an internal fixator, so all the materials are human friendly, and does not cause any harmful to the human body. So for the appearance of the product is aimed to be simple and might be different depending on the type of tibia fracture. The product must not contain too many parts and do not have any sharp edges, as this can cause harm to the user. So in total for our morphological chart, we have about 6 concepts. And so we have 6 concepts for the blade and 6 concepts for the screw. So after our discussion, we have conduct 2 different scoring metrics, each for the blade and for the screw. So as we choose which for our tibia blade, we choose for the first concept for the blade and the 5th concept for the screw. And this screw. Yeah, so moment.
Then for the final decision, we choose this product because the reason is this product have the simplest part to design, as that is what we target for. And then this product also very easy to build and very easy to install, as also it do not have any sharp edges, and it also do not cause any inner or other side damage. And this product can also be minimized weight by the custom product. You can minimize the length of the product, so you can minimize the weight also. So you can tackle type of many fracture tibia because it can make many shape and as you want to support the fracture. Then it can be modified to any posture according to fracture. Can be adjustable. The next.
And so this is our product features and part specification. This is our plate. And magnet and the screw together. So this is our assembling drawing, which is after rendering, and our exploded view. Yeah, and we also attach our internal fixator to the bone, and it is perfectly matched also. And yeah, for the mechanism.
And then for the mechanism, we got mechanism. Firstly, we put a plate on the bone to mark the hole to put the plates, and then just drill the mark, and then we put the pin in the hole like the picture. Then lastly, we just screw the plate. It's very easy to install. And next.
So for the material and the cost, this is the price per link. So from our research and calculation, the cost per link is very cheap, which is maximum for around 5 ringgit. So for one set of our chain consists of 4 links. So one set will cost around 20 ringgit, but this is the only raw cost. This is not include any hidden costs such as shipping, packaging, or even the installation costs. Next. So in conclusion, to what we observe and based on our reviews, we are sure that the objective of the project successfully achieved. We aim to propose a tibia fixator that is like less complexity and able to be installed to any tibia, any type of tibia fracture. We also have figured out many approach to improve our invention and idea. Not only that, we also discovered that this chain fixator is very handy and suitable for almost all patients, although they have different sizes. This fixator is not only focused for adults, but they also suitable to be installed on child. We would like to thank our lecturer, Dr. Ardian Shah bin Shahrul, for the advice and assistance that he gave us in order to complete this project. Furthermore, this project exposes students on how to get a proper approach to the existing product and how to identify the problem. When the problem is successfully identified, students were guided on how to find solution and improvement correctly. Than that, students also be able to learn more of SolidWorks. All students already learned on how to draw in SolidWorks before, but in this project, students were able to sharpen their skill and knowledge about SolidWorks. Last but not least, the value of team working were experienced by all the students. All students work together in their team to achieve the objective of the project. The tasks were divided among group members so that the project can be done smoothly and complete in a given time. This project also helps students to gain new knowledge about science and technology, especially in biotechnology field. Students were exposed to safety and health standard for internal fixator, and our design too must follow the safety requirement. That's all from us, Group 4. Thank you.
Okay, thank you very much for the group 4. Yeah, I think that is interesting. Yeah, I think Zadatul boleh jadi inilah ni, the sound what effect. Okay, I think any question from the other students. Yeah. If not, we continue first. Yeah, we continue with the group number 1. Yeah. Okay, who another one? Anis, who's another one? Chia. Okay.
Chia.
Okay.
So, yeah, good evening, everyone. So, good afternoon, everyone. So, we are from Group 1, and we are going to present about our design knee implant. So, our group members are Chong Lee, Yusuf Mohammed, Said Jalangjing, Hanis Marisha, Dina binti Hamidi. So, yeah, for the introduction, design a knee implant which can be used by the knee patient from the young teenagers with juvenile arthritis to the elderly patient with degenerative arthritis. So the main purpose for this knee implant is to resurface the parts of the knee joint that have been damaged and to relieve the knee in pain that cannot be controlled by other treatments. So for the importance of the project is the reason for knee implants knee replacement surgery is to relieve severe pain caused by the osteoarthritis. People who need knee replacement surgery usually have problems of walking, climbing stairs, and knee pain. So for the patient need to perform knee arthroplasties in knee joint by cutting away the damaged bone and cartilage from the tight bone, shin bone, kneecap and replacing it with prosthesis made of metal alloys, which can be seen from the picture is the femoral component and tibial component, and high grade plastic and polymers which is the spaces between the femoral component and tibial component. So for the problem statement, we target the customer groups in which are the individuals who are facing knee fracture and knee implant that cannot be controlled by other treatments. They require an implant to conduct daily activities, and the high cost of time and money to go back and forth from the hospital to treat the knee pain. And the objective of this project is to design and develop an implant to aid the target customer group to their daily life activities. And also, we have to design an implant to resurface the parts of the knee joint that have been damaged and relieve the knee pain that cannot be controlled by other treatments. Lastly, to develop an implant that is affordable to the target customer group. So, the related works that we have done before is the minor project of introduction of design, which specified an internal fixator for fracture of human bones. And for the problem to be solved in this design is the corrosion problem of taper, which the threaded taper design provides more surface area for corrosion to occur, and the rafted matting surface of the female bones predisposing the interface to service corrosion. And the problem of femoral component is attune the radius curve and the glider articulation, logic lock, tibial base locking, and lastly the logic tibial base locking mechanism. So we proceed to Marisha.
Okay, so next we will move on to our product design specification. So first, weight. The weight of this implant is between 15 and 20 ounces, around 425.243 gram to 566.99 gram. So the product is targeted on individuals who are facing knee fracture and knee pain that cannot be controlled by other treatments. So the quantity of our product is 1 unit, and the maintenance is the second operation is required if the patient has a knee replacement at a younger age, and the maintenance may not be required for elderly people except for those who are facing infection, instability, stiffness, wear and tear of knee implant. And our product lifespan is 15 to 20 years. Next, for the implant component, we have 4 components, which are femoral component, polyethylene spacer, tibial component, and patella component. So for the femoral component, the design is grooved so that the kneecap can move up and down smoothly against the bone as the knee bends and straightens. Second one is polyethylene spacer. The polyethylene spacer paired with the tibial component replace the top surface of the tibia, so the femur glides along the surface. So next, tibial component. It withholds the polyethylene insert, and the components are designed so that the metal articulates against plastic. It will provide smooth movement and minimal wear. And lastly, we have patella component. The shape is dome shape of polyethylene, which is identical to the shape of the patella, and it will glide in the groove of the femur. So for the concept that we propose, as you can see from the slide, we have 8 concepts, which is the first and the second one is proposed by Chia Liang Jing. The third and the 8th one is mine, and the 4th and 7 is from Ng Chong Li, and lastly 5 and 6 is from Yosef. So next I will give to Ng Chong Li.
So our final design is concept 3 from Marisha. It has femoral component, spacer, and tibia component. And we add another extra component which is patella component. So the material for the spacer is plastic, which is polyethylene, and the thickness is thick about 8 mm. And the material for the femoral and tibia component is titanium, which is biodegradable to our body. And the weight of these 4 components is medium. So next slide. This is our quality function deployment. So as you can see from the customer, we put our priority the most at the lightweight. And next. This is our evaluation matrix. As you can see, we put our priority at lightweight and small size, with lightweight get 50% and the small in size get 20%. And we also put our consideration at cost, which is 15%, and the maintenance 15%. So our design concept 3 get the most higher mark, which is 4.3, and which is rank number 1 in our 8 design. So I give to other presenter.
Okay, now we will come to the product features. First of all, it's not rejected by the body, so it will be biocompatible. The product duplicates the knee structure, so they are intended to replace. The product is strong enough to take the weight and be able to lift the body weight. The product is also flexible, and it moves smoothly against each other as required. The product retains its strength and shape for a long time, so the patient is not required to change it frequently. The product can let the knee bend to around 120 to 25 degrees of flexiation. So the mechanism, we first prepare the bone, the damaged surface at the ends of the femur and tibia are removed along with a small amount of underlying bone. Position the metal implants, the removed cartilage and bone is replaced with metal components that recreate the surface of the joint. These metal parts may be cemented or press-fed into the bone. Resurface the battle, the unsurface of the battle kneecap is cut and resurfaced with a plastic button. Some surgeons do not resurface the battle, depending upon the case. Insert a spacer, a medical grade spacer, plastic spacer, and is inserted between the metal components to create a smooth gliding surface. So as we can see, these are the prices we can find online by the currency of the US dollars. For the formal components, it's around 320 bucks, and the tibia component is around also 320 bucks. The spacer is around $125, and the last is patellar component. It's around $55. At the last, we would like to thank you all for listening.
Okay, so I didn't see yet on the rendering model. You have?
No, I forgot to do it and it was too late.
You still have times, to rendering. Let's say in the tomorrow.
Yeah, I'll try to do it by today. Yeah, sure.
Okay, so I want to know that is yes, that is agree. You can develop the patella. Why you have the idea you construct the patella for that specific design?
Excuse me?
Why you have the patella design in your knee implant?
Oh, you mean the small circle?
Yeah.
Oh, so basically this was to hold the small bone in front of your knee. So
I
we
know
took
that
the
is
idea.
there is small bone in front of the knee. Normally we can use the patella unless there is a fracture in the patella or there is a disease on the patella. That is mostly very rare. But the shape of the patella is like I don't know. There is 3 point over there.
Yeah.
Which is you put in I don't know where you put in the location in the patella actually.
You put it above the let me check from name again. The femur component. Yeah.
Okay, that during the movement they will slide in. It's not fixed to.
No, yeah, but it's still far. Like it's above. It's far from the Like I mean, when it slides, it will not scratch the plastic spacer.
Yeah, the patella actually sliding. You previously slide, please.
Excuse me.
Previously, okay. Okay, next slide. Next slide. Another one. Okay, here. Okay, actually the patella, no, that previously slide.
The one before, yeah. Before and after, yeah.
Okay, this. Okay, this patella actually slide in the middles. There is the curve. Yeah. If you see the shape of the patella is not straight. Yeah, it's not the straight. Yeah, that is you need to give the arguments. Yeah, why your patella is the flat surface. And where you want to put the patella actually. Which connection? Yeah, that is I try to encourage something. If you put just fixed to that position, I think it's not really a crack.
Oh, it was like it was like brought up by someone of us, so we just took the idea and applied it, but we didn't think about it.
I agree. You provide the patella, but you need to improve slightly. Yeah, slightly improve. Maybe you can see the shape of the patella, then how the slide in. Yeah, slide to the knee. There is a curve actually in the knee. That is the point. Their slide as a guidance. Also the guidance of the bones. Okay. That is a small input from me. Yeah, I think you can improve whatever you can. After that, you submit the reports by tomorrow. Yeah.
Okay, sure.
The report is you can submit 11 past 59 p.m.
So
Yeah.
before 12 a.m.
Yeah, before 12 a.m. Okay. Thank
So
you very much to all. Yeah. Uh,
okay, thank
okay.
you.
I will call our friends here. From congratulations to all. Yeah. You have finished your project. Okay. Maybe I want to hear a few words from our friend here from Universitas Airlangga, Erika Medina. Can you, Erika? Okay. Nisaul? Yuri Tuna? Firda? Ronald? Ronald? Are you there? Rahma Ajeng? Maybe to all of you can voice out maybe I don't know who. Why everybody is keep quiet?
Prof, di sini sedang azan.
Oh, okay. Thank you, Rahma. Okay. Any comments, yeah, to all in my group, yeah, in my students. There is 16 students here. Any feedbacks, regarding of this class? Yusuf, Pangjing, Waiting. I don't know. Maybe you can give any feedback to me. Yeah.
Yes, we really enjoyed your class. Like I enjoyed it, talking about me, and it was really like very honorable for me to know you as a person. You were very good as a lecturer and as a teacher for me. And I really enjoyed this subject with you. Yeah.
Okay. The negative side you have?
No, actually,
Just
like
asking,
this was
I did it not affect to your mark,
no, no, I
Yusuf.
don't. No. I don't mean anything, but really, it was maybe the only subject I enjoyed this semester. So
See, yep, make a laugh to you.
no.
Yep, you have something, yep.
No, sir. No, sir.
Thank you,
You have
sir.
negative side. You can voice out. I'm happy to hear you here. No problem. It's not affect your mark really. Okay, Marisa, you have something? Anybody? You can, Marisa?
No, sir, I'm happy this time.
Happy this happy to this class only. Yeah. Waiting. I believe you have something different. Waiting. Hello, waiting. Nurul Fatihah.
Yes, sir.
Yeah. You have any negative side from me? You can voice on, so at least for next semester I can improve somehow.
No, sir. I'm happy over here.
Pang. Pang Jing Tiang. Moment.
Yes,
Yeah. You have something to say here? You can.
thanks. Thank you, Doctor.
Huh? You have something? No? Razali. Said Razali.
Yes, sir.
Yeah. You have something to say here?
No, sir. Good.
Only good. Okay. So, thank you, Razali. So, I don't know why our friend here from Universitas Airlangga just keep quiet. You know, Erika, Medina, you have any comment? Maybe you are confusing. Maybe I can thought some things. Yeah, Nisaul, Rama Ajeng, Ronald. Please voice out some things. Yeah. No? Okay, maybe you to sigh. Yeah? Okay, I have I will give another brief to you later. Yeah. I will arrange with the Prof Suryani to arrange another class maybe. Okay. Thank you to everybody. Yeah. Today is the last day our class. Yeah. I am happy to I'm happy and enjoy teach to all of you. Yeah, I'm happy to enjoy teach all of you. I think you are quite active. Yeah, quite active. Maybe you can ask something. I'm more than happy to do that. You know, and I hope whatever I teach to all of you, you can bring to another class. You know, that is the design process. It's not only about the a good or bad, but how you can use the design process to improve. Yeah, to improve something. Okay, to improve something to the way you propose something. Yeah, that is another point of view actually. Okay, Lale, how are you? You
Fine,
you are,
Prof.
yeah, how are
Alhamdulillah.
you? You are really late.
Nah,
You know, we will end off the class. Maybe we can arrange
yeah.
another meetings. You know.
Okay,
Okay.
Prof.
Okay.
Sorry, I just read the message. Okay. Thank you, Prof.
Okay, no problems. And I believe, yeah, with this knowledge you can use to apply with another subjects, yeah, especially in the how you thinking, yeah, thinking skill, that is will affect. You will make something is there is a process, there is sequence, yeah, there is a sequence that you need to follow. Afterwards you can able to propose something good, yeah, in your family, in your community, even in your country. Okay, thank you very much. If I have something wrong, I really apologize. Yeah, I really apologize to all of you. Hopefully we can meet another subject, yeah, to handsome and beautiful students today, yeah, in my class. Okay, in the introduction to design. Really, I say to thank you very much to all of you. because your attention and everything. Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon. See you then. Bye.
See you next time, sir. Bye.
See you.
Yes,
Bye.
sir.
Bye.
Thank you, sir.
Most
It was
welcome,
an
Yusuf.
honor to meet you, sir.
Yeah, most welcome, Yusuf. I will end the meeting now. Yeah.
Okay.